The next time you look into someone's eyes, you aren't actually looking at a black dot. You're looking into a literal mathematical black hole.
Which sounds crazy, I know.
It really does. But welcome to today's deep dive, where we're going to completely change how you think about looking around the room you're sitting in right now.
Yeah, because usually when we think about human vision, we rely on a very comforting, very mechanical metaphor.
Right, the whole camera thing.
Exactly. We tend to think of the eye as a biological camera. The lens focuses the light, the back of the eye takes the picture, and the brain just develops the film.
It's a comforting metaphor because it implies this linear, passive reality. Like, you open your eyes and the world just pours in exactly as it is, fully formed.
Right. But when you step into the world of quantum biology and advanced neuroscience, that camera metaphor completely falls apart.
And that is exactly what we're tearing into today. We've got a fascinating stack of source material that blends quantum biology, neuroscience, and what you might even call, 4D philosophy.
It's a wild ride.
The mission of this deep dive is to explore the staggering reality that your eyes are not just biological cameras, they are quantum data intakes.
And your brain is essentially a holographic projector.
Right. We're going to unpack mechanisms that sound like pure science fiction, but are actively happening inside your skull right this second.
And to understand just how bizarre human vision really is, we have to start at the point of entry.
The pupil.
The pupil. This is where the outside universe physically meets the human body.
So let's start right there, because the source material makes this wildly provocative claim right off the bat. It suggests that the pupil of the eye acts like an atomless black hole.
Yeah, that's a bold one.
Right. Now, the author asks a very logical question to back this up. If light is pure energy and sunlight is constantly bombarding the open pupil of the eye, why doesn't the inside of the eye physically heat up and burn?
It's a great question.
So how do we reconcile this? Is the pupil actually an atomless void in our face?
Well, we have to separate the biological reality from the geometric physics the author is pointing at.
Okay, lay it on me.
Biologically speaking, the eye is absolutely packed with atoms. I mean, behind the pupil, you have the aqueous humor and the vitreous humor.
Those are the fluids.
Yeah, these crystal clear fluids made mostly of water molecules, so H2O, along with suspended proteins and salts. You also have the physical tissue of the retina itself. So it is definitely not a vacuum in space.
Yeah, okay, so it isn't a literal tear in the fabric of the universe.
No. But the author is touching on a brilliant physiological concept to answer that question of why the eye doesn't cook itself.
Right, the burning question.
Exactly. Normally in physics, when photons of light hit an object, they cause the atoms in that object to vibrate. That molecular vibration generates heat.
Like wearing a dark shirt on a sunny day.
Perfect example.
Yeah.
But the eye bypasses this using a mechanism called quantum transduction.
Quantum transduction.
Right. When photons of light enter the eye and strike the photoreceptor cells on your retina, that light energy doesn't just sit there vibrating the atoms of your tissue.
Because if it did, we'd go blind.
We'd cook. But in a fraction of a microsecond, before it can generate any significant heat, that quantum energy is instantaneously converted into pure electrical information bits.
Okay, let's unpack this for a second. So it's less like a magnifying glass focusing a beam of light to burn a hole in a dry leaf.
And more like a highly advanced solar panel.
Right, because a solar panel doesn't try to absorb heat. It instantly turns the sunlight into an electrical current.
The solar panel is an excellent way to picture it.
Yeah.
And, to take that engineering marvel a step further, even though quantum transduction is incredibly efficient, a tiny fraction of residual heat is still generated.
Just from that constant bombardment of photons.
Yeah. So to handle this, your eye has a built-in liquid cooling system.
Oh, wow.
Just behind the retina is a dense layer of blood vessels called the choroid. It acts precisely like a radiator in a high-performance engine. It instantly absorbs any residual thermal energy and disperses it deep into the body's rushing bloodstream. It literally carries the heat away from the delicate optical tissue. It is a masterpiece of thermal engineering.
That answers the heat question perfectly. So biologically, we have atoms, we have rapid data conversion, and a radiator.
Right.
But the text keeps coming back to this phrase, calling the pupil a black hole. Where is the author getting that from if it's full of fluids?
So geometrically, the source is completely accurate. The black pupil in the center of your eye is not an object.
It's not a thing.
Right. It's not a black liquid or a patch of dark tissue. It is an aperture. It is simply a hole in the iris.
It's literally just a window looking into a dark room.
Exactly. And the reason it looks pitch black to an outside observer is because of what happens to the light.
It doesn't come back out.
Exactly. Photons enter that hole, hit the retina, and are entirely absorbed by that quantum transduction process we just talked about. Zero light reflects back out.
That's wild.
And in the realm of physics, any point in 3D space that absorbs 100% of the light entering it and reflects absolutely none, well, it appears perfectly black.
Ah, so in a very real mathematical sense, your pupil operates as a micro black hole.
Precisely. There is no physical wall stopping the light at the surface of the eye. It is an open cosmic gateway that does nothing but swallow quantum data from the universe.
That is just wild to think about. Every time you look at someone's face, you aren't looking at a black dot. You're looking into an event horizon where light goes in and never comes back out.
It really forces you to realize that our bodies are deeply integrated with the physics of the cosmos.
So, okay, if the eye is this micro black hole sucking in cosmic data, where does all that information go? Naturally, we assume it flows straight down the optic nerve into the brain.
Like a one-way street.
Right, but the source material introduces a massive twist here. It claims the flow of information isn't just a one-way street from the eye to the brain.
And this is where things get really interesting.
Yeah, because the text makes a very bold, specific claim here. It suggests that the sclera, which is the white part of the eye, actually shoots protons from the brain back out into the world.
Yeah, so we need to gently correct the physics on that specific claim.
Just a bit.
Just a bit. Living tissue does not emit protons. Protons are heavy, positively charged subatomic particles locked inside the nucleus of atoms.
So we aren't firing proton lasers out of our eyes at the world.
Sadly, no. Anatomically, the sclera is an opaque, dense muscular wall. Its evolutionary job is to be totally light-proof, keeping the inside of the eye completely dark so that the incoming light from the pupil doesn't scatter and degrade the image.
It functions exactly like the solid walls of a photographic darkroom.
Right. But we cannot dismiss the author's underlying premise.
Yeah.
Because the theory they're pointing toward...
A two-way street thing.
Exactly. The idea of a massive two-way feedback network between the eye and the brain. That is one of the most profound proven truths in modern neuroscience. The author's intuition that a one-way street isn't enough to explain vision is absolutely spot on.
Wait, I'm trying to wrap my head around this. Why would the brain send info back down to the eye?
It seems counterintuitive.
Right, because if the eye is taking in all this data, isn't the brain just the hard drive receiving the files? Why would a hard drive send massive amounts of data back to the camera lens?
To understand why, we have to look at a relay station deep in the center of the brain called the lateral geniculate nucleus, or the LGN.
The LGN.
Right. When those electrical signals leave your retina, they travel down the optic nerve and hit the LGN. For a long time, scientists assumed the LGN was just passively receiving all this bottom-up data from the eyes and passing it along to the visual cortex at the back of the head.
Makes sense.
But neuroscientists found something shocking. The visual cortex actually sends massive bundles of feedback connections top-down back into the LGN.
Wait, really?
Yes. There are significantly more pathways going backward from the brain down toward the visual system than there are coming forward from the eye.
That sounds completely backward. What is the brain possibly sending back down the line?
Predictions.
Predictions.
Yeah, this is known in neuroscience as the predictive brain theory. The universe out there is a chaotic, infinite flood of quantum noise. Photons bouncing off every dust particle, every shadow, every texture.
It's too much data.
Way too much. If your brain tried to process every single photon in detail hitting your retinas in real time from scratch, your neural circuitry would be overwhelmed instantly. You would freeze.
So it cheats.
Basically. The brain doesn't just sit back and watch the world. It actively projects an internal 4D model of what it expects to see based on your memories, your current context, and your environment.
Oh, I see. So if I walk into my kitchen, my brain already has a massive database of what a kitchen is supposed to look like.
Yes. Before you even fully open your eyes, the brain is sending electrochemical waves back down the visual pathway saying, we are in a kitchen, expect to see the refrigerator on the left, filter out the complex shadows on the floor, they aren't important for survival, focus on the sharp edges of the counter.
It's essentially prepping the canvas. It's telling the visual system what to ignore and what to pay attention to before the light even fully registers as an image.
It is a continuous dynamic loop. The eye sends up the raw data, and the brain sends down its knowledge and expectations to shape that data.
Wow.
So it's not shooting physical protons out of the sclera, but it is constantly projecting a neurological expectation outwards, filtering the cosmic noise into a reality you can actually manage and navigate.
Okay, so we've got this micro black hole swallowing light, instantly turning it into electrical data, and the brain is heavily filtering that data using this top-down predictive loop.
Right.
But that brings us to a mechanical problem that just breaks my brain a little bit. The retina's at the back of our eyes, biological screens capturing all this incoming light.
Yeah.
They are completely flat. They are 2D surfaces. The eyes are only capable of capturing two-dimensional images.
Like a curved sheet of photographic film. It has height and width, but zero depth.
So how on earth are you, the listener, seeing a rich, three-dimensional world with depth and volume right now? If your biology is only handing your brain flat photographs, where does the 3D room come from?
This brings us to one of the most incredible mathematical computations your body performs. It's called stereopsis.
Stereopsis.
Yeah, and it all hinges on a very simple anatomical quirk. Your two eyes are not sitting in the exact same spot on your skull.
Right, they're separated.
They're spaced roughly 6.5 centimeters apart.
Hmm.
Because of that physical gap, your left eye takes a 2D photograph from one angle, and your right eye takes a slightly different 2D photograph from a slightly shifted angle.
Mm-hmm.
We call this binocular disparity.
Wait, let me actually try this right now. If I hold my finger up right in front of my face.
Yeah, everyone listening should do this.
Okay, so I hold my finger up and I close my left eye. Okay, now I switch and close my right eye. Oh, wow. The finger's jumping like 3 inches back and forth against the wall behind it.
Right. That shifting jump you just saw is the raw data of depth.
That's crazy.
And here is how the brain uses it. Both of those flat 2D electrical signals travel to the visual cortex. The brain then superimposes these two flat images on top of each other.
Like layering them.
Exactly.
Yeah.
It mathematically calculates the microscopic pixel differences, the disparity between the left image and the right image.
Okay.
If an object, like your finger, shifted a massive amount between the two images, the brain calculates that the object is very close to your face. If a tree in the background barely shifted at all, the brain calculates the disparity is low, meaning the object is far away.
Oh, that is so smart.
By running this intense geometric calculation on millions of points in real time, the visual cortex mathematically generates a brand new dimension out of thin air. It creates the z-axis, depth.
Here's where it gets really interesting. Out there in the real world, it's just raw light waves bouncing around.
Yep.
But inside the pitch black vault of my skull, using nothing but math and 2 flat photos, my brain is generating the z-axis. My brain is running a real-time 3D virtual reality simulation.
That is the perfect way to understand what the source material means when it describes the brain as a cosmic sculptor or a holographic projector.
It's literally a hologram.
Think about a physical hologram plate. It is just a flat, two-dimensional piece of glass or plastic. But when you shine a laser on it at the right angle, a three-dimensional image appears in the air.
Right.
Your brain is doing the exact same thing. It takes the 2D input from your retinas and, using the laser of neural processing, projects a 3D reality simulation inside your mind.
The 3D room you feel like you're sitting in right now doesn't actually look like that. The depth itself is a mathematical construct generated inside your head.
A highly accurate, survival-tested construct honed by millions of years of evolution, but a construct nonetheless.
Okay, a 3D hologram is amazing, but holograms are made of light. When the photons hit the micro black hole of our pupil, we establish that they undergo quantum transduction.
Yes.
They turn into raw electrical impulses. A spark of electricity doesn't inherently have color, right? It's basically just black and white Morse code.
Spikes of voltage. There are no red or blue pixels traveling down your optic nerve. It is silent, dark electricity.
So how does the brain unpack this cosmic mail? How does a silent, dark, black and white electrical shock get painted into the rich, vibrant, fluid reality we experience? How do we get the red of an apple or the smooth motion of a bird flying?
This is where we look at the brain's grand routing station, the thalamus, and specifically that LGN area we mentioned earlier.
The relay station.
Right. When that raw black and white electrical data arrives, the LGN acts like a massive quantum demultiplexer. It instantly splits the signal into 2 distinct parallel processing paths.
Like separating the audio and video cables on an old TV. You send one signal to the speakers and one to the screen.
Very similar. The first path is called the magnocellular pathway.
Yeah.
This is a very fast, ancient, evolutionarily primitive neural route.
What does it do?
It strictly processes motion, speed, and course depth. It doesn't care what an object is. It doesn't care if it's red or green. It only cares where it is and if it's moving towards you fast.
Pure survival instinct. Is that blur jumping out of the bushes going to eat me?
Precisely the point. You need to react before you even know what it is.
Makes total sense.
The second path is the parvocellular pathway. This one is significantly slower, but it carries incredibly dense information about light wavelengths, fine details, and sharp contrast.
But the signal is split into motion and detail. But where does the color come from? How does this actually become a picture I can see?
The split data hits the visual cortex, which operates like a microscopic assembly line with 5 distinct substations, numbered V1 through V5.
Okay.
V1 is the primary reception area. It just sketches out the basic 2D map of lines and contrast. V2 and V3 take those simple lines and start calculating geometry, corners, edges, and the boundaries of objects.
So building the wireframe.
Basically, yeah. But the text specifically highlights the magic that happens in V4 and V5.
Let's talk about V4, because if the electricity has no color, something has to be inventing it.
V4 is the color decoder. The universe out there doesn't possess color as we feel it. It only have electromagnetic wavelengths of different frequencies.
Just waves.
Right. V4 takes those abstract mathematical wavelength frequencies from the parvocellular pathway and literally paints the simulation. It maps a specific frequency to a subjective experience. It generates the feeling of red, the feeling of blue, the brightness of yellow. Wow. Without V4, the world is grayscale, even if your eyes and retinas are functioning perfectly.
That is mind-bending. The redness of an apple only exists inside the V4 processor of my brain.
Exactly.
What about V5?
V5, also known as the MT area, is the motion matrix. It calculates how these painted objects are moving through the fourth dimension, which is time.
Okay, so it handles the animation.
Yeah, without V5, life would look like a choppy strobe light party. You would see a car down the street, and then suddenly the car's right in front of you, with no smooth transition between the 2 points. V5 strings the static frames together so you perceive smooth, fluid motion.
So the assembly line is working perfectly. You've got V4 painting the color red, V5 calculating the smooth trajectory through the air, V2 drawing the round shape.
Yep.
But I still have a problem. How do I know what I'm looking at? How does my brain know that this red, round, moving blob is a thrown apple and not a baseball?
To assign meaning to the simulation, the brain uses 2 massive neural highways that branch out from this visual assembly line.
Where do they go?
The first is the dorsal stream, which heads up toward the parietal lobe at the top of the brain. We call this the where is it pathway. It grounds the object in spatial reality so you know exactly where to reach your hand to catch it.
Okay, and the other one?
The second is the ventral stream, which heads down into the temporal lobe. This is the what is it pathway.
Ah, so this is where the raw data finally meets memory.
Precisely. The ventral stream takes the red, round shape and rapidly compares it against your entire lifetime database of memories, words, and concepts. It matches the pattern, assigns the conceptual identity of an apple, and delivers that cognition to your conscious mind.
If we trace this all back, the colors processed in one physical area of the brain, the shape in another, the fluid motion in another, and the identity in yet another.
Right.
They are geographically separated, so they don't actually exist together as a unified apple in the brain until the very last possible millisecond.
You've just hit upon what scientists call the binding problem.
The binding problem.
Yeah, it is the grand finale of neuroscience. The color, the shape, the motion, they are all fragmented data bits processed in totally different regions of your neural tissue.
It's just scattered pieces.
Right. It is only your consciousness, that overarching 4D awareness, that stitches all these fragmented streams together in a fraction of a second to create the seamless, unified, singular experience of reality you are having right now.
That's incredible.
How physical matter creates that unified conscious experience is still one of the greatest mysteries in science.
It is absolutely mind-blowing. Let's just summarize the journey of a single photon of light that we've mapped out today.
Let's do it.
It travels across the vacuum of space, enters the mathematical micro-black hole of your pupil, and is instantaneously converted from physical energy into electrical data through quantum transduction, bypassing heat.
Yep.
That data is then heavily filtered by a top-down predictive feedback loop from your brain telling you what to expect. Those flat, 2D electrical signals are compared across a 6.5 centimeter physical gap to mathematically generate the 3D depth of a holographic simulation.
Skill tracking.
And finally, that raw data is split onto an assembly line, painted with subjective color in V4, given fluid time in V5, and matched to your memories to give it meaning.
When you break down the mechanism step by step, you realize that seeing isn't passive at all. It is an incredibly active, computationally massive act of creation.
Hmm.
You are quite literally building the universe inside your mind, frame by frame, every single millisecond you are awake.
Which brings me to a final thought I want to leave you with today. We talked heavily about the predictive brain, about how your visual cortex sends massive amounts of feedback down to your visual system to predict and project what you expect to see, filtering the data before the light even fully arrives.
Right, prepping the canvas.
So think about that for a second. If your brain is constantly laying down its own expectations and memories over the raw cosmic data,
Yeah.
how much of the room you are sitting in right now is objective reality and how much is just a hallucination generated by your own past?
It completely shatters that old camera metaphor we started with. The camera isn't just taking a picture of the outside world. The camera is projecting the photographer's mind onto the canvas.
The lens works both ways.
Oh.
Well, thank you so much for joining us on today's deep dive. Next time you look in the mirror, remember, you're not just looking at a dark circle, you're looking into a quantum gateway. We'll see you next time.